Hello, Artun Chunkar here with you again. Welcome to the first video of new playlist. In this video, I'll take you through the process of how we can create opening and closing, kind of a dynamic facade panels. And I'll be showing all the steps that you need to take to create that facade kind of panels on this very basic panel here, as you can see in my screen right now. So without any further ado, let's jump in. This is my folder where I save my videos, and now we are in our Rhino Microsoft screen. So basically what we are going to do is, by the way, you may see a couple of different layers which I'll be talking about in the next videos, where we connect our facade panels to the spaces that we have in our schematic plan. So what we are going to do here is basically creating sort of a motion that opens up and closes on the facade or this glazing. Let's say this is a glazing. So what I need to do first, I will create a curve and I'll import this curve from Rhino. Obviously, there might be some changes over the process, but this is the very simple logic explanation of facade, uh, conceptual facades that we are going to deal with. And what I'll be doing is I'll need basically the middle line of this curve. So I'll be exploding this curve because I'll need the segments. I'll say explode. And then what I'll be doing is I'll be having the segment. There are a couple of ways to grab this segment that I need, but the best and I think the most reliable way to do is to find the lowest positioned segment, line segment on this rectangle. And we can do that by sorting our segments by the midpoint of each segment's coordinates. So if I grab a point on curve component, oops, not this one, point on curve, and if I grab this one, and if I go to vector point deconstruct, and I deconstruct it, and if I connect Z over here, what I'll be seeing is, let's grab a curve to my values. We'll have 4 different curves, lines. What we can say here is we can put a list item, and the very first item of this list is going to be the one that we need, which is this. Why we are using this? Because what I'll be doing is I'll be creating that motion, facade motion, here on this very first line of our panel, let's say. I can group this all just to proceed a bit further. But then if I am going to create this curve while I'm opening and closing it, what I'll be needing is I'll be needing sort of a point where I'll be stopping this opening or closing motion. Because if I just imagine if you're folding a paper on this, you need sort of a length, like limit, right? Like limitation of the length. And we can define that by using shatter and also by using evaluate, because I want you to see where we are trimming, not trimming, but splitting the curve. So if we type 1.000 and connect it over here, and if I right click to reparameterize it and I make it this, maybe I'm looking at it from the way around. Yeah, this is the right direction. And if I do the same things for here, if I say reparameterize and then connect this curve, let's see what we are going to do. But one thing I want to do here, I want to make this wire display hidden and connect it over here and then group this, but then adding a sphere on this one and change its radius to 0.05 maybe. See how it looks. It's too small right now. Maybe it's okay for now. Why I did this? Because I always want to control where I am adding this, you know, like control point. Because when I change this, you'll see that I have one line piece segment here, one line piece segment over here. And in this way, we can create like sort of an asymmetric view of, or sort of an asymmetric organization with the same principle. Then what I'll be doing is I'll have two line-like curves. Then what I'll be doing, I'll be dividing these, right? I'll just divide these curves. Let's start with the first one. I'll be doing the same for the other one, but I'll just put a list item so that you can easily follow the principle that I'm mentioning. So I divide this curve into two, because what I'll be doing is I'll be taking this point, midpoint, and I'll be rotating it by putting this one onto our center, and then I'll be rotating it. So what I'll be doing again is, like, let's say list item. This is my point 0, but just in case I'll be putting in my index as 0, and I'll be copy this and paste, and this time I'll be putting 1 here. Data, and now I'm having my point. As I said at the beginning, what I'll be doing is I'll be rotating this point on XY plane of this guy, and maybe what we can do, just to give us a bit more space here, and the angle, if I grab a radians, you'll see that if I connect like I don't know, 0 to 360, you'll see that it go out of bounds. You see that it goes all over the place. But what I need is, I need something ranging between 0 to maybe 0.0 to 90, and then connect it over here. And then if I connect this one, see it comes over here and then goes over here. As you see, this is the first motion, but what I need is, when I have this point here, I need to have another point over here so that they are going to be connected, right? Like the mirror of this point. We can do the mirror by using a mirror component, but there is a better way to do that. Okay? And what is that better way? So if I just, for now, if I just group this guy and group this guy and group these guys, okay, maybe I can group this into another group. What I'll be doing is I'll be doing the same similar operation for this point. Okay, sorry, for this point. And how I'll be doing that? So I'll grab another rotate component. I'll be putting the rotate component. This is going to be my rotation. This time, maybe I can pull out a point so that we'll have a bit more space here. And XY plane, obviously. But this time, this plane is going to be fed by this point, so I can connect this to here. Okay, and maybe I can just wire this plane here, connect it over here. And this is going to be my plane. So if I pull out radians, if I connect this value here, you see, when I do this, it goes the other way around, right? But what I really need is the angle that is left from 180, because when we have 180, it's a straight line, right? How can I do that? If I create an evaluate, meaning we can create an expression here, and if I type my expression like 180 minus x multiplied by 2, if I connect it over here, it will be all red, because we have to define the variable x as x rather than, sorry, maybe I can take it a bit further. Hold on. So when we see variable x, we have to put in variable x in our expression. And if you don't have a variable x in your expression, it's not going to work, and it will give you, as you see, it's an invalid name. So I will just put an x here. I will take this off, and I will connect this guy here, and the result is going to be my radians. And when I put this in, let's see what is happening. You see now, it's going all over the place. But since they are now different, of course they are working all differently. But if I connect this one over here, what I'm seeing is, maybe I can preview this all off, and I can delete you. I can delete you guys as well. So I have this one, I have this guy, and let's see what's happening. You see, it's supposed to go onto the direction that I'm requiring, but what it does instead, it goes all over this rotation, all over this direction. And there's an easy fix to overcome this problem. That is caused by our rotation plane, because we need to rotate our point, which is this point, onto this plane, not this plane, not this point. So if I could take this and connect this to my plane, then what I'll be seeing is this can stay, this can stay. Now what I can see is I am having my points all over the place. And now obviously what I'll be doing, I'll take you out of this group and I'll put you in this group, another group, so that we know, like we can say this is the first wing in a sense, right? This is the first wing, and maybe in that end what I can say is I can group these guys as well, but just a slight red. Here, and this is going to be very, very red, and this time this is going to be in this group, and if I connect it over here. And last but not least, what I'll be doing is I'll start with my point 0, which is like we can merge my point 0, which is this one. I can grab this guy over here and the last one over here, and then say polyline, right? And what I can do next is to extrude this one on Z direction, right? And what we want to probably do is to define the height of our panel. So in this case, we can just leave it as it is, or what even we can do to prepare ourselves for the next exercises, but let's not do that. That might make things a bit more complicated. So for just this case, let's get the measurement, and it's 5 meters, so put 5 here and then put it in. You may think now, okay, we did all this, but what is the point of having our parameter here? You see why we are having this, because we are not doing anything. What this basically does is actually when we turn it on and off, so let's say it's 0 and it's 90, 0 and 90, what we are going to see is when we add the other panel, we are going to see how they are going to be opened, or their position of or the glazing is going to receive more sun, less light, more light, kind of a thing. But that's pretty much it for this video. And as you see, we can play around with this. And in the next one, we'll be finalizing this panel by adding couple of adding the next one onto this portion and adding more control onto this one. See you next one.